Alright, trig basics. Full instruction. You have to memorize patterns. Memorize 30, 60, 90. Short leg is x. Hypotenuse is twice that. Long leg is x root 3. So I have this 2 here, and if I look at my pattern, I take my x and I double it. This has to be twice a 2, which is 4. I have a short leg of 2, and again, if I multiply it by root 3, I would literally have 2 times root 3. 2 root 3. Alright, this guy's got a pair of congruent sides, which means I have a pair of congruent angles, which means they both measure 45 degrees. So I'm thinking about the 45, 45, 90 pattern, which goes x, x, x root 2. The congruent sides is a dead giveaway that x is 2 root 3. Don't be that kid who does not know what x is. And the hypotenuse is found by multiplying by this root 2. And 3 times 2 is 6, so we get 2 root 6. So that's an easy problem. Hopefully those go well. Alright, number 3. After finding the hypotenuse for the triangle below, write the 6 trig ratios for angle A. Always simplify your radical. You're going to have to do a little Pythagorean theorem. So a squared plus b squared is a c squared. And it doesn't matter which one's a and which one's b, but these are your legs. Don't be that kid who thinks c is 12. C is a hypotenuse. I've always been amazed how many kids that I didn't teach geometry will use 3 as a hypotenuse, like whatever. But anyways, 3 squared plus 12 squared must be c squared. 3 squared is 9, 12 squared is 144, and that is c squared. If I push buttons or whatever, 9 and 144 is going to be 153. That's 153 is c squared. Or sorry, it's just c, because I take the square root. I didn't show that, but I guess I should have. I got ahead of myself. And the only way to get that, oh, I'll be darned, that actually does factor. 153 is 3 times 51, and 51 is 3 times 17. So this is 9 times 17. So this ends up being 3 root 17 when everything's said and done. Obviously, I'll give you partial even if you can't simplify the radical, but you know you need to. Depends on how bad some of this looks. Alright, now for my ratios. Most people use the acronym SOHCAHTOA. That's what most people do. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is the reciprocal. Sine says O, cosecant is a ho. Secant is a reciprocal of cosine. Cosine says ah. It's cosine's a breath of fresh air. Secant's a funny guy, says ha. And then cotangent is the reciprocal of tangent. And tangent says oa. Cotangent says ao. And there we go. All of our tensions on angle A. Now opposite of angle A is a 3. The hypotenuse is 3 root 17, and 12 is the adjacent side. Notice I'm labeling things. So opposite over hypotenuse would be 3 over 3 root 17. The 3's cancel. 1 over root 17. I do not like having radicals in the bottom, so I multiply top and bottom by root 17 over root 17. 1 times root 17 is root 17, and a radical times herself is the number inside. So root 17 over 17. Alright, adjacent over hypotenuse is going to be 12 over 3 root 17. 12 over 3 is 4. 4 over root 17. And I'm a little low on paper here. You know, most kids do not do all this work. Most people don't do this work. This work is for you, not me. 4 over root 17. I multiply top and bottom by root 17. And I get 4 root 17 sitting pretty over 17. If this is beyond you, you're not going to be an engineer. That's all I can tell you. Tangent's going to be opposite over adjacent. That's 3 over 4. Sorry, 3 over 12. I don't know what I'm doing. 3 over 12, which is 1 in 4. All right, the cosecant ratio. I got this all too close for me to write. Cosecant is hypotenuse over opposite. So it's 3 root 17 over 3, which is just root 17. It's not hard. You could have flipped it right here too. Cosecant is the reciprocal of sine. You could have flipped. Secant is hypotenuse over adjacent. So secant is going to be 3 root 17 over the adjacent length of 12. 3 over 12 is a quarter. So root 17 over 4. And the last thing is cotangent. Cotangent is the reciprocal of tangent. Tangent was a fourth. Cotangent is 4. Or 12 over 3, which is 4. Alright, that one's out of the way. You know, I teach this stuff. I know how bad this is going to be for some of y'all, because your apathy is just tremendous. Nothing I can do about apathy. Alright, draw the following angles. First one up's 210 degrees. You have to draw the XY axis. There's no ifs, ands, or buts about it. Now, an angle will always start, if it's drawn in standard position, on the positive x-axis. It starts here. And then it rotates. This is positive. We rotate counterclockwise. We actually rotate left. This would be 180 degrees of rotation, and then I need 30 more, which is about a third of a quadrant. And there we are. There's a 210 degree angle. Negative 5 pi over 6 is going to rotate clockwise. The first thing I'm going to do is I'm going to take negative 5 pi over 6 and I'm going to convert it into a degree. So I'm going to multiply it by 180 over pi, and you're more than welcome to do this in a TI-84. It's up to you. You can push buttons. I'm not going to push buttons because I don't really like being a button pusher. The pi's cancel. 180 over 6 is 30, and negative 5 times 30 is negative 150. So a negative 150 degree angle, and again we start always on the positive x-axis. You were supposed to learn this last year. It was not taught to you. At least I don't think it was taught to you. But we rotate 150 degrees like a clock. So this would cover 90. So think about adding 90. I have negative 60 degrees of rotation left, which is going to cover 2/3 of quadrant 3. There's my angle, negative 150 degrees. 900 degrees of rotation. If I travel full circle, I'm in the same place. So what I do is I take away 360, and then I take away 360 again, because I can. 900 minus 360 twice is going to be 180 degrees. How about that? Now, as far as rotation, she's positive. This is a counterclockwise rotation. And if you start on the positive x-axis, I thought I changed colors there. You start on the positive x-axis, you'd only rotate to here. Now what actually happened is we rotated once, twice, and then half. That's what the angle actually looks like. It's actually a straight angle. Who would have thought? Alright, on 4 I've got 2 pi over 3 radians, and it's kind of the same deal. I'm going to take it, I'm going to multiply it by 180 over pi. 3 enters 180 60 times, pi's cancel, 120 degrees of positive rotation. I wish I could make this easy for everybody. Some of y'all, though, it's like you hadn't really tried since about 4th grade. I rotate 90 and then another 30. And there's my angle, 120 degrees of positive rotation. Notice the arrows I'm using? The arrows signify direction. It's part of the deal. Alright, moving forward. Using the inverse trig function, find angles alpha and beta and show me whatever inverse functions you used. Alright, so I'm going to do alpha, and you can do it any way you want because you have every side of the triangle. Okay, so if I'm going to focus on angle alpha, my alphas never look right. But if I just look at these two, opposite over hypotenuse, I know that the tangent of alpha is equal to 5 over root 13. Therefore, alpha is the arctangent of 5 over root 13. So I'm going to pull up my TI-84. I'm going to make sure that I am in degree mode. So I have to be in degrees. And I'm going to hit second tangent. Maybe. Of 5 divided by root 13. I'm going to get about 54.20 degrees. Now, if I don't like the tangent ratio, I could have done any other ratio. I could have maybe played with sine. I could have also done, or I could have done the arc sine of 5 over root 38. But I get the same thing. Second sine, 5 divided by root 38. Oh, it's the same thing. So anyways, I have alpha. I do. I'm going to do beta using trig. Let me get rid of these because now I'm looking at beta. Just erase all that. Focusing my attention here. Now this becomes adjacent, this becomes opposite, and that's still the hypotenuse. And just to change things up, let's do cosine. I know that the cosine of beta is 5 over root 38. Therefore, beta must be the arc cosine of 5 over root 38. You know, I know there's a couple of kids like, Mr. Milbrath, just take away from 180. Of course you can do that. I'm trying to teach you trigonometry. That's what I'm trying to teach you. I'm trying to teach you how to use your ratios. 35.80. Moving forward. Use the law of cosines to find angle C for the non-right triangle below. And I gave you everything you need. If you never figured it out, this would be lowercase c, because lowercase c is opposite of capital C. Capital C is an angle, lowercase is your sides. So we're just going to substitute in. And this can be A and this can be B or vice versa. It doesn't matter. So this 15 goes here. 15 squared equals 9 squared plus 13 squared. Minus twice 9 times 13. Times the cosine of angle C. And then we're just going to do some math. Like, what is 15 squared? Pretty sure it's 225. Right? Maybe. 9 squared is 81. 13 squared is 169. Let's see, 9 times 13 is 107. If you double that, you get negative 214. 9, 27, 107. Yeah, I'm good with that. We're going to be subtracting this stuff over there. I'm going to take away the 81. And I'm going to take away the 169. I didn't want to miss this. I get negative 25. Let me make sure I squared 15 right too, because I'm not feeling quite right in the head right now. Whew, good, I did. Alright, so anyways, there's a negative 25 on the left. I'm equal to negative 214 cosines of angle C. And what I'm going to do is I'm going to isolate that cosine ratio by dividing by negative 214. And now I know that the cosine of angle C is 25 over 214, which means that the measure of angle C must be the arc cosine of 25 in 214, which means I'm going to push some buttons. Second cosine 25 sitting pretty over a 214, and she's about 83.29 degrees. Moving forward, that was cosines, must be law of sines. And she is. The formula is given to you right here. So the sine of 99 is going to compare to 12. That's all it is, sine to a side. As the sine of 21 degrees has to compare to side B. And then we're going to do this little old cross multiplication idea. B, and I'm going to make that an uppercase, sins of 99 degrees is equal to 12 sins of 21 degrees. And to isolate this B, I'm going to counter out my multiplication with division. Oops, forgot the sine function. And this is my answer. Let's see what she says. 12 sins 21 divided by the sin of 99, 4.35. Ta-da! An angle named theta intersects a circle centered at the origin of radius 13 at the point -5, -12. Draw it out and find the 6 trig ratios for the angle. Technically it's a reference angle that you're doing, but whatever. And go with it. So we have a circle centered at the origin of radius 13. The point -5, -12, which would be somewhere in here, because remember this is 13, right? That's 13. Intersects the circle. Now let's talk about getting to this point. There's a lot of ways to do trig. There are a whole lot of ways of doing trig, and I'll probably do this thing 2 different ways. To get to this point, what I did is I went left 5, and then I went down 12. And the radius is given in the text as 13. We'll throw our reference angle right here at the origin, theta prime. And now we'll do our ratios. Sine ratio is opposite over hypotenuse. So opposite's a -12, hypotenuse is 13. The cosine ratio is adjacent over hypotenuse. Adjacent is a -5, hypotenuse is 13. The tangent ratio is opposite over adjacent. Opposite is a -12, adjacent is a -5, a negative over a negative is a positive. Sine says O, cosecant is a ho. The hypotenuse is 13. She's sitting over 12, but that 12 was negative. Put the negative symbol in the numerator. Secant is the funny guy. Secant says ha. Hypotenuse is 13. Adjacent is a -5. Put the negative in the numerator. Tangent says oa. Cotangent says ao. Adjacent is a -5. Opposite is a -12. A negative over a negative is a positive. Easy peasy Japanesey. Now there's another way of doing this, and I should have taught this lesson by the time you take the quiz. It's the circular approach. Now the circular approach says sine is the y-coordinate over the radius, cosine is the x-coordinate over the radius, and tangent is y over x. Now if sine is y over r, cosecant is r over y. If cosine is x over r, secant is r over x. If tangent is y over x, cotangent is x over y. So you see your points, x, y, r. So if you can remember your circular ideas, we'd have negative 12 over 13. This would be the reciprocal. 13 over 12, negative in the numerator. Cosine is x over r, negative 5 over 13. Beneath it would be her reciprocal, negative 13 over 5. Tangent's y over x, negative 12 over negative 5, which is 12/5, and cotangent is its reciprocal, 5/12. Easy peasy. Triangle has side lengths of 6, 10, and 12. What is the area of this triangle? This is not going to be a right triangle. We have side lengths of 6, 10, and 12. And what we're going to have to do is we're going to have to use Hero's formula. It looks like Heron, but it's Hero's formula, which says that the area of a triangle is the square root of s times s minus a times s minus b times s minus c, where s is the semi-perimeter. Now, the word semi means half, so it's a plus b plus c over 2. So let's find s. S is going to be 10 plus 6 plus 12. Sitting pretty over a 2. That's going to be 28 over 2, which is 14. A, B, and C are just these guys. You can pick any one you want. A, B, C. Why not? Doesn't really matter. It does not matter. All that matters is that things are plugged in right. So my area is going to be the square root of 14. This is going to be 14 minus 6. The next one's going to be 14 minus 10. The next one's going to be 14 minus 12. Alright, so we got a 14. That's going to be 8. That's going to be 4. That's going to be 2. And I'm going to probably be a little mean on this because I think kids need to know how to simplify radicals. Because why not? "14 is 2 times 7. 8 is 2 times 4. 4 is, we're going to leave 4 there. Then we have a 2. Now let's put some stuff together. If I put these two guys together, I've got another 4. So I've got a 4, square root of a 4, times a 7, times another 4, times another 4, times a 2. Each one of these square roots of 4s is going to be a 2. 2 times 2 times 2. Gone, gone, gone. Inside 2 times 7. 2 times 2 times 2 is 8. Inside is a 14. There's my area. 8 roots 14. I know some of you don't believe this magic that I do up here with numbers, but say you're only smart enough to push buttons. I would have 14, 14 minus 6, 14 minus 10, 14 minus 12, which is that decimal right there. And I'm saying, unless I screwed up, who Lord knows I do, that that's the same as 8 root 14. And they are. One of those is beautiful, one of them is not. One of them is math, one of them is pushing buttons. Triangle has two side lengths of 12 and 15 centimeters respectively. If the angle between them is 30 degrees, what is the area of this triangle? Exact answers only, zero rounding. So we have a triangle. She has side lengths of 12 and 15. And the big thing is that the angle between them is 30 degrees. And by the way, it's not given. Like, we don't know that it's a right triangle. We do not know this. It is not stated to be right. About the only way you can do this is if you put 30 degrees in a random spot. That's about the only way you can do it. Now, by now, I have told you a formula. It says the area of a triangle is 1/2 AB sines of C. So here's a side A, here's a side B, and C is the included angle. So this guy would be 1/2 of A, which is 12, times the 15, times the sine of 30 degrees. Now, these things are not hard. The sine of 30 is going to be 1/2. See? Sine of 30 is 1/2. Always has been, always will be. I got 1/2, I got a 12, and I got a 15, and I got another 1/2. 1/2 of 12 is 6. 1/2 of that 6 is 3. 3 times 15 is 45. Alright, a square has a diagonal of 5√6. What is this square's perimeter and area? So I draw myself a little square. I have a diagonal that measures 5√6. I know that to find the area of a square, I take a side and I square it. I also know in my heart 45, 45, 90, x √2. To find one of these side lengths, I take the diagonal, which is the hypotenuse of 45, 45, 90, and I divide it by √2, and I get 5√3, because √6/2 is literally a singular radical that has 6/2, which is 3. And moving forward with my life, I take 5√3 and I square it. And to square that, you square both pieces. This is 5 squared times a root of 3 that is squared. 5 squared is 25. √3 squared is 3. And I get 75. And I think I got one more. And then I'm done with trig basics. I hit that button again. An equilateral triangle has an altitude of 6√6. The height is 6√6. Now I'm going to take a look at the right hand side because that's what I do. These are 60-degree angles because she is equilateral. This is the long leg of an equilateral triangle. The short leg is going to be the long leg divided by the root of 3. And 6/3 again is 2, so it's 6√2. That is half. Remember, half is 6√2, 6√2. The whole thing is going to be 12√2 because 6 plus 6 is 12. Area of a triangle has always been 1/2 base height. Always will be. So this would be 1/2 of a 12√2 times 6√6. 12 times 6 is 72. 2 times 6, √12. Do better. √12 is √4 times √3. √4 is 2. 2√3. So I have 72 times 2√3. 72 times 2 is 144. 144 roots of 3. Welcome to geometry. Should have learned it last year.